Hello guys, I am here with you. Today we create a simple machine learning project that recognize handwritten digit. So first of all, we explain little. I explain a little about the project. So this is a simple machine learning project for digit recognition using popular MNIST dataset. We will use Python and TensorFlow and Cross for building neural network model to recognize handwritten digit that started from zero. First of all, first step in we install necessary libraries. So here we write a command to install required libraries. So then we TensorFlow, and other one is NumPy and matplotlib is then we run this command. Here we install the required libraries. It's take a little time. Once then we import another shell where can where I can load MNIST dataset from TensorFlow and Cross, and then build a training a neural network, and then train our neural network. Then of at the end we evaluate model and make some predictions on our trained model. So here I will comments and write import library. So first of all I import numpy as a np, and other one is import TensorFlow as a TF, and then we import layers and models from TensorFlow, from TensorFlow, TensorFlow from TensorFlow dot keras, keras import layers and models. And the second thing, we import our plotting some digit in. So we need to import a matplotlib. Import matplot. Here is matplotlib dot py pyplot as a plt. So here we can run this cell and put another code cell to write another code. Here we can load our MNIST dataset. Load the data set here. So I create a MNIST variable. Then call our TensorFlow tf dot keras, Here was brought on datasets dot yes. Here we call this and then move in and run this cell and import another cell to create another. Then we spelled our datasets in the commands here we can split our dataset in train and test. So write a logic here to create x train, y train, x test, and y test. So we give first of all we created x train, y train, y chain, and in our next array we can create x test and y test. So we call here MNIST variable over we create on upper cell that we load data, and we load it and then run this cell, and then that's our create. Here we print our x train to show our data. Here we mistake and then solve it. Here our data set this show error because I write a C, so I will remove it. So then we again run this cell. Yeah. Then after run above cell, then we run this cell. Show it did not show error here. So here we check our output of xtrain. So the next step we create our neural network. First, I think we normalize our dataset because our digit pixel value between 0 and 1. So hmm, first of all we normalize our dataset, then move next to create a neural network for training purpose. Here we can write for code to normalize our data xtrain and xtest. Then after xtrain dot to 50/50 or 0 for xtest. Same procedure for xtest. So here we can normalize on both and run the cell. Now we are able. Now we build a simple neural network. Here we comment build a simple neural That's a neural network. That's on a neural network we train our model. So, um, neural network model. That's good. First of all, we create a model. For models, I will import from TensorFlow libraries. That's sequential call here. Here we can create layers dot dash. We will import input shape. Input shape. We write input shape size. In the first layer, we define our input shape. Then in the next layer, our next layer depend on for we define our next layer in a dense layer. Dense that 1A128 and the we write activation. That layer will define the pixel of image. Here we comments and write I write activation layer grid and dropout, and the next layer we create a dropout layer dot dropout dropout 0.2 error, and at the end we again create a soft layer that on a dense. Here we can write soft max. After this, creating our model, basic model, then we run this cell. After creating our model, then we compile our model. In compile model, compile, we define optimizer Adam and loss. Here we can define loss. We create, we use categorical cross entropy. I think it's And the next we create a matrix accuracy. A metric. Here we can go run this, compile this cell. So model even create. So then yeah, here we create a test loss and test accuracy. After we evaluate. Here we evaluate our model, train on our data set, test, and here we can write y test, x test. Here I think x is capital and y is small. So that's why no, they did not do this because first of all we'll train our model on our data set, not evaluate first. Model that fit model dot fit x train x train y train, and then we provide epoches epoch 5 and then run this cell. I face not interpret loss identifier. So here we can search on internet what is the mean. The cross entropy. I will copy this and paste here. I think it's a spelling mistake. So here, right, and then compile again, and then run again this. Here we go. I think I will mistake in a spelling, so that's why our training not start. So when I change and remove spelling mistake, then our emojis run. Our training procedure is final, so I evaluate. So now I evaluate our model. So move to next step. We print accuracy. So here I print accuracy of a model. Here, here can call test accuracy. Here I we achieve 0.997 accuracy on our pre-trained model. So first of all, we achieve 0.97 accuracy. Then we next step we make a prediction. We make some prediction on new dataset. So predict we create a predict variable model that predict. We check our prediction on X-test now to import a new dataset. So here we can call X-test. I think X is a capital. Then we also print predict. So I am able to show is our prediction long. So I will create uh, plotting to display our outputs. So first of all, we create a plt matplotlib plt dot im show show show. We call our xtest first values and cmap. Then we next plt dot title of our graph. Here we can pass our prediction 0. So in the next line, we will show our plot. Show it's 7. So I will change our output, then check what is on one position. So here we can change and replace with 1 to 2, and then we see the prediction. And in 2 position, we show our 1. So that is a simple project that we create in a TensorFlow. And if you like this video, like and subscribe my channel. Thank you for giving me time.